Hey guys, it's me, Chavez. I'm going to go over the 2025 AP free response questions. There's a few here. There's three here that are shared with the BC. So yeah, I reformatted it. All these questions belong to College Board. They're not mine. And this is just for educational purposes. I'm going to go over these with my kids as well. I have one kid right now currently with me after school. And yeah, we're going to hit it up and we're going to see what's up. We're going to look at these questions. I haven't done them per se, but when I was typing them out, I kind of was thinking about like what it was. So yeah, so let's see how we do, and let me know if I make mistakes, guys. Just put it in the comments, and I'll fix it. I'll fix it for the next iteration. All right, so here we go. So the very first question, these are calculator active. It says an invasive species of plant appears in a fruit grove at time t equals 0 and begins to spread. The function c defined by c of t equals 7.6 arctan. I think they literally spelled arctan, but I just put 10 to the negative 1. That's the same thing, guys. Arctan of 0.2t models the number of acres in the fruit grove affected by the species t weeks after the species appears. It can be shown that c prime of t equals 38 over 25 plus t squared. They're being nice. They didn't have to do that, but maybe to even the playing field, for kids that may have a CAS calculator. Letter A. Find the average number of acres affected by the invasive species from time t equals 0 to time t equals 4 weeks. Show the setup for your calculations. Okay, well, let's see. What do they want? They want the average. The average of what? Number of acres affected by the invasive species. Well, this C of t is the number of acres in the fruit grove affected by the species. So what they're trying to tell us is that they want average of C of t. So here we go. I'm going to go 1 over 4 minus 0 integral 0 to 4 of C of t. It does not have to look like this, guys. You can have the integral from 0 to 4 of C of t dt divided by 4. You can come in. Sorry, guys. It's really hot here in South Texas. My room's probably like 85 degrees, and outside it's probably like 198. Oh, okay. So here we go. So type this into your calculator. So I have my calculator, so I'm going to type it in. So here we go. I'm going to go y1 or y equals, and I'm going to type in, I already forgot, short-term memory, 7.6. So 7.6 arctan of, and again, 0.2t. Thank you. 0.2x there. All right, there it is, my y1. And just for kicks, I might need it, so I'm going to put this one into y2. That's my derivative, 38 over 25 plus t squared. So alpha y equals, enter, 38 over, and you don't have to, but if you don't use your parentheses, I think it's best to use that alpha y equals feature, 25 plus t squared. You could also use delta math. Shout out to delta math. You could also use Desmos, 25 plus x squared. All right, I think we're good. 35 over 25 plus x squared. I don't see any issues. Okay, here we go, guys. I'm going to take my calculator, and I'm going to make it look like that exactly. I'm going to go alpha, enter 1/4. And I'm going to go math, number 9. That's the integral here, 0 to 4. And I have the C of t in y1. So the way I get it is alpha trace. And here are all the values, all the y equations that you can get. I put it in y1 with respect to x. And there it is, at least 3 digits after the decimal. If you want to put more, that's fine. 2.778224. 2.778. 2.778. 224. Does that look familiar? Hopefully, okay. If you wanted to put units, you don't have to. Let's see. This is the C of t is in acres. Well, it's acres times time, right? What was time again? And what did they say anywhere? Weeks. So acres weeks divided by the change in time. So weeks. So this is acres. And I don't see any issues. I think we're good. Find the average number of acres. Show the setup of your calculations. I think we're good, guys. I don't see any issues. I think we're really good. All right, letter B. Find the time t when the instantaneous rate of change of C, instantaneous rate of change of C equals the average rate of change of C. So this is literally MVT, mean value theorem. Over the time interval 0 to 4, show the setup for your calculations. To use the mean value theorem, in case you don't remember, and I shouldn't be using the letter F because we're using the letter C here. The letter C, so so this is what my mean value theorem is, and again, muscle memory, I'm using the letter S. C of B minus C of A over B minus A. Where's your average rate of change? Equal to your instantaneous rate of change. Well, I already have C of T right there. I have that in Y2 in my calculator, and I have this in Y1, so I'm going to go C of 4 minus C of 0 over 4 minus 0. This is going to be my average rate of change for C. So I'm going to take my calculator and I'm going to get my little fraction thingy here, numerator, denominator, and I'm going to go alpha trace y1, that's where I have my C of t, evaluated at 4, minus alpha trace y1, evaluated at 0. And I'm going to divide that sucker by 4. 4 minus 0. And there it is. That's my average rate of change. So I got 1.28200. 28200. I'm going to store this to A. You don't have to necessarily show that within the problem here. You can just go, now I want to go where the instantaneous rate of change, see, equals 1.28200. So I'm going to go into my calculator here, and I'm going to write store into, and I'm just going to go down the alphabet. I'm going to store that into A. So now I'm going to click on Y. And remember, Y1 is your C of T, so I'm just going to turn that off. And I'm going to go to Y3, and I'm going to type in alpha A. And now, let's see. I'm only going to look between 0 and 4. And look what the number is, 1.28. So what you're going to do, you're going to click on Window, and you're going to go between 0 and 4. And you already know the value is 1.28, the average rate of change. So what you're going to do, you're just going to make your Y values somewhere between there, right? 0 to 3 or 0 to 4. It does not matter. And so there it is. When I graph, I'm looking for the intersection. Does that make sense, guys? Or Montanes? Okay. Graph. And there it is. So there it is. And you don't have to go to 3. You could have gone to 2 if you wanted. I'm looking for that intersection. Guys, tell the calculator to do it for you. That's an intersection there. Second, calculate number 5. And then enter. You only have 2 curves right here that you're displaying. So guess. If you have more than one intersection, you would go to the one that you want. There it is. 2.1542993. 2.15422. Okay, hook me up, Montanes. T equals 299. Okay, perfect. 2993. Not that I needed it, but thank you, Miss. What do you think so far, Miss? Pretty straightforward, pretty cool. Good stuff. You like it? All right, let's go to the next one. Letter C, assuming that the invasive species continues to spread according to the given model for all times t greater than 0, write a limit expression that describes the end behavior, underline end behavior, of the rate of change in the number of acres affected by the species. All right, guys, so I want my end behavior, rate of change. Rate of change is the same thing as saying, yeah, like derivative. So they want the end behavior of C prime of t, guys. So I'm going to write limit and it says end behavior, so I'm going to write as t approaches infinity. And I guess if you write the letter X, if you squint, the X looks like a T there. But of C prime of T, and you don't have to. I mean, they're giving it a name. I would use the C prime, but you can write it as 38 over 25 plus T squared if you want. I think this is appropriate. I think it's appropriate. I'm not saying that it's going to be appropriate for all situations, but I think this is okay. And I'm just going to write what the end behavior is. So 38 divided by a huge number. What is that going to approach? What do you think? Take a guess. I mean, you also have a calculator, by the way. 1 divided by 1 is 1. 1 divided by 10 is 0.1. 1 divided by 100 is 0.01. 1 divided by 1,000 is 0.001. What do you think this output is approaching? 0. Yeah, 0. The bottom's getting larger, and the top is just 38. So 38 divided by a larger and larger number, you're going to be approaching the 0. Sometimes I say you're decreasing, and you're always decreasing. But more negative numbers is also -5, -10, -20. So you're converging to the value of 0. Hopefully that made sense, guys. Yes, I know there's always someone that says, hey, write the expression for C prime. That's fine. I would be okay with the C prime, but maybe you're not. And that's just difference in philosophies and in the way we all teach. I'm okay with seeing limit as t approaches infinity for c prime of t, but if you want to write the expression, that's fine too. There's no big deal. You're fine. We okay so far, Montanes? All right, perfect. All right, let's go to letter D. It says, by the way, guys, on letter C, you have a calculator. So you could have just looked at your calculator. You know what I mean? Okay. On letter D, later, miss. Have a good one. At time t equals 4 weeks after the invasive species appears in the fruit grove, measures are taken to counter the spread of the species. The function a, defined by a of t equals c of t minus from 4 to t 0.1 times ln of x dx, models the number of acres affected by the species over time interval 4 to 36. At what time t between 4 and 36 does a attain its maximum value? Justify your answer. Okay. We attain a maximum. So notice we're in a closed interval. You should probably look at I'm trying to have good habits here. You should always check for a maximum at your endpoints and check for critical numbers. I get a critical number whenever the derivative equals perfect. So I'm going to set my derivative equal to 0. So here's what I got to do. I got to take a derivative first. A of t equals, and then this is just my fundamental theorem of calculus, right? So the derivative of c is just c prime. And then I'm taking the derivative of this integral. So minus, it's going to be itself, right? Because the derivative of the integral, so it's going to be minus 0.1 ln of t. Close it, and I'm going to go equals that to 0. Now you have a calculator. So use your calculator. This is called my setup right here. I'm going to go to my calculator. I'm going to go to y equals. I'm going to turn off y1 because that was c. I'm going to go to y2. That's your c prime. I'm going to turn off y3. And I'm going to go to y4, and I'm going to go y2. So that's my c prime. Minus, and then I'm going to type in 0.1 ln of t. 0.1 ln of x. Are we still okay? Hey, take a seat, man. Go for it. Here, let me give you a...
No, you're good. I'm just...
Oh, there it is right there. You want to grab it?
No one decided to stay in.
Well, Montanes is here, so... All right, so here it is. There's y4. This is your derivative, Montanes. So I'm going to click Window, and I'm going to go... What am I going to do with my window? I'm going to go from what to what? Yeah. Perfect. 4 to 36. 4 to 36. You only care about where you cross the x-axis, but... X scale, it doesn't matter here if you want to go by 5s or by 1s. All right, so I'm going to go y min, I'm going to go -1. And y max, I'm going to go 1. If you want to go -2 to 2, that's fine. And why did I do that? Because I only care about where I cross the x-axis. Does that make sense to you? Oh, look, check it out. Why do I have 2 curves? I forgot to turn off y2. Turn off y2. And if I push graph, all right, look what's happening. I'm going to go a little higher. A little higher and a little lower. -2. Maybe I'm making the graph uglier. Who knows? Nope. Should have gone. It doesn't matter. I think we would have been fine with what we had. -1 to 1. All right. Look at this. The derivative starts off positive. And it's always positive. There's my derivative curve, right? It's always positive until I cross the x-axis, or t-axis, I guess, technically. And then once I cross that point, is my derivative always negative? Yes. So this must mean, sorry guys, if there's noise in the hallways because it's after school and we got kids roaming the hallway. This must mean that I must have an absolute maximum at this point where I change from positive to negative. Because I'm always positive between 0 and whatever that value is, and I'm always negative between that value and, what was this, 36? Does that make sense? Okay, so here's how I'm going to write it. First, let's find that intersection. Second, calculate, and I'm going to do which one? No, not 5. 0, because the y value is 0, right? That's the derivative. Left bound, I'm going to put 1, enter. Oh, okay, my bad. Maybe I should have used the scroller. Maybe I don't exist at that. Left bound, second, calculate. Let me do it again, just in case. Number 2, 0. And then I'm just going to scroll to the left. Oh, yeah. It said error because my left bound here is, what was it, 4? Yeah, so it's outside the window range. Right bound, go to the right of that x-intercept. Boom, boom. And there it is, 11.4417. So let's see. If I put x here, okay, see how it keeps going? I would store that. X store alpha b, just in case I need it for the next section. Or is that the last? That's the last. Oh, never mind. I'm not going to need it. All right. So here we go. Yeah, I can see that. All right. So I'm going to say this. This happens. A prime is it happens. A prime is 0 when t equals 11 point. What was it?
44169985.
Okay. And then here's how I'm going to answer it. You can always do a table if you want it, but I'm going to answer it like this. I'm going to say absolute. I'm going to say A attains its maximum value at t equals, sorry guys, I'm dying here with this heat here, 44169985, since a prime is positive on 0 comma to 11.44169985. You don't have to be this this specific. And a prime is negative on 11 point, oh, and I already see a mistake, 4 to 11.44169985 to 11.44169985 to 36, comma, hence apps max must occur at t equals 11.441699. Does it make sense? Okay, let me read it again just in case. A attains its maximum value at t equals 11.44169985. Since a prime is positive on 4 to 11.44 and a prime is negative on 11.4416, hence absolute max must occur at t equals, yeah, perfect. We're saying that the derivative is positive between this specific interval, derivative is negative between this specific interval. I must have an absolute max right when that derivative changes from positive to negative. Does that make, are we good? Okay, are we happy? Okay, let's go to the next one. The shaded region R is bounded by the graphs of the functions f and g, where f of x equals x squared minus 2x, and g of x equals x plus sine pi x, as shown in the figure. All right, so hopefully we can tell, we all took pre-cal, you can tell the linear and sinusoidal properties is this one, plus they give it to you, gx, and this guy's f of x, perfect. Find the area of R, show the setup. First thing I would do, I would plug this into my calculator and plug this into my calculator. Do we want to go in alphabetical order and put the f on y1 and the g on y2? Okay, so I'm going to go y equals, and what was the equation for y1?
X squared minus 2x.
Okay, what was the equation for y2?
X plus sine pi x.
Sine pi x. Okay, I think we're good. I know there's probably a teacher or someone looking at this video like, just reset your calculator. It's a lot faster. That's fine. No big deal. Sorry, guys. I hope you guys are happy. Find the area R. Show the setup of your calculations. Okay, here we go. Area R is equal to integral from, and it looks like they gave it to me. Sometimes we have to find that intersection, but we all took pre-cal. If I plug in a 0 here, yep, your y value is 0. If I plug in a 0 for the g of x, 0 plus sine of 0 is 0. So, yep, 0, 0. They both share the same y value at the origin. So, 0 all the way. And it looks like they both share the same y value at x equals 3. And then what curve is always on top? Yeah, what curve? What's the name of that curve?
G of x.
G of x. All right, G of x. Minus what curve is always on bottom? There it is. And then dx. If it bothers you, put parentheses here. But it's understood that the dx is the end of that integral. So here we go, guys. I'm just going to go integral 0 to 3 gx minus f of x. So I take my calculator, and I'm going to go to the home screen, and I'm going to go math 9. You could also use Desmos if you feel more comfortable with that. From what to what? 0 to 3. And I'm going to go alpha trace. I have my g on y2. Just remember where you put them. Minus alpha trace y1. Hopefully I didn't make any errors, and if I did, please let me know. Did you get the same values, Montanes? 5.1366? Let me know if we didn't. You got them? Okay. So here we go. I'm going to come in. I'm going to put an equal sign. And what does that equal?
5.1366.
Okay. All right, we're good. We're good. We're real good. How do we feel? That's f of x there. All right, letter B. Region R is the base of a solid. For this solid, at each x, the cross-section perpendicular to the x-axis is a rectangle with height x and base in region R. Find the volume of the solid. Show the setup for your calculations. I love it. I love it. I hope you love it too. Look, guys, when you do a cross-section, it told me it's perpendicular to the x-axis, right? At each x, cross-section perpendicular to the x-axis. So there's my cross-section. The height, it's coming out of this board. And here it is. So I'm going to just draw something random here. It's not going to be perfect. There's my rectangle. This height is x. It's coming out of the board. It's coming out of this of my laptop here like that, flat. You know what I mean? All right. So that height is x. But this distance, this here right here, the width, if you want to call it the width, it's this. Okay, I guess I'll write it here. This green is this right here. So that green, imagine it's like, you know, and it's coming out of the board. So the top curve, the top is what again? G of x minus, there it is. And remember, for the volume, because it wants volume, right? It says find the volume. We're going to add up an infinite amount of cross sections. So I have to do a what? Yeah, and it's perfect. You're winning. So check it out. You're going to go volume equals, I'm going to go integral from what to what? 0 to 3. And then I just need my area cross section. How do I find area of a rectangle? Base times height. So I'm going to do what times what? Well, what's my height? X times. Perfect. Close it, dx. There it is. Averaging out an infinite amount of rectangles there from 0 to 3. Type this into your calculator. I'm going to take my calculator and I'm going to go math. Number 9 from 0 to 3. And then I'm going to go x times, and then g of x minus f of x. Remember that g of x is on what? In the calculator. No. Y2. Y2 minus alpha trace y1. And there it is. Did you get the same answer? There we go. What values do we get?
7.7049296.
Perfect. Ooh, man, this room is getting really hot. I'm sorry, guys. It is the best we can do. All right, letter C. Write but do not evaluate an integral expression for the volume of the solid generated when the region R is rotated about the horizontal line y equals -2. Okay, it doesn't have to be perfect. You don't have to be perfect here. We're rotating. I guess that's fine. We're rotating, I guess, y equals -2 there. So if I were to keep going, let me see. Let me see if I can do this. Let's see. Increasing, so decreasing, increasing, concave down, so decreasing, concave up. Ah, man, that's not even close to. It's not going to be perfect. That's fine. You don't have to be perfect, guys. Notice I'm not perfect. I'm not anywhere near perfect. And then it looks something like, let's see. It's just a rough sketch. It's not perfect. You can see, so sorry guys, I'm not perfect. I apologize. All right, so look at this. Look at this. I'm going to go ahead and do my cross section right there. And this, again, I got a D in art. That's a true story. I still don't know why I got a D in art, but that's okay. All right. There it is. There's my, what shape is that? It's a washer. How do I find area of a washer? Yeah, pi big R squared minus pi. Yeah, there's big R, that's little r. I would not write that anywhere there. This is not part of that problem there. It is a washer, so let's make it look. Here we go. So I'm right here. So I'm going to go volume equals, so I'm going to factor out the pi. So here's my pi. Integral. And I'm going to integrate from what to what? 0 to 3. And then giant parenthesis, big R. Big R is the distance from, I'm going to do it here in green, from the -2 all the way to that top curve. We always said top minus bottom. So I'm going to write, tell me what I'm going to write inside this curve, inside this parenthesis.
Big R.
Yeah, so what's, how do I get big R? What curve is that? This top one way over here. Oh, it's g of x? Oh, that was on me. Thank you. G of x. You're right. G of x minus negative 2, which turns into a, yeah, plus. Close it and put a what on it? Squared. And here we go. Now I'm going to do the other one. Minus, open parenthesis. What is the distance of this one here? How do I find that? What's that reference for how do I find that radius in R, the little r? What? Oh, did I? Oh, man, I'm sorry. That's my fault. I'm all over the place. I did it again. To this curve from here to here. This distance. Yeah, that's f of x. F of x minus, yeah, minus a negative 2, so it turns to a plus 2. Put a square on it, put a dx. How do we feel? Okay. I didn't confuse you, did I? Okay. It is getting really warm, and it's been a long day, and yeah, I'll stop because I know that a constant iteration of saying warm maybe gets to your head, and you're like, oh my god. All right, letter D. Oh, that's it, right? Because it says do not evaluate. So we're good. Do you feel good? Okay. If your mom's here, tell her to come up. Tell her to come upstairs. Okay. But if she's here, tell her to come up. Maybe she wants to see some of this calculus, All right, letter D. It can be shown. Come on in, guys. Come on in. It can be shown that g prime equals 1 plus pi cosine pi x. Find the value of x between 0 and 1 at which the line tangent to the graph of f is parallel to the line tangent to the graph of g. Okay. If you're parallel, what do parallel lines have in common? No. What do parallel lines have in common? They never touch, which means they have what? Okay, what about the slope? They have the same slope. Yes, you got it. They have the same slope. So look, if it can be shown, this is g prime. G prime tells you the slope of g at any x value, right? Find the value of x between 0 and 1 in which the line tangent to the graph of f is parallel to the line of graph of g. Okay, well, the f is this. So I'm going to take the derivative of f because the derivative of f tells me my slope of how f behaves for any x value, right? Do you know what I mean? So here we go. I'm going to go f of x equals, and what was f of x? X squared minus 2x. So f prime of x, what's the derivative of x squared? What's the derivative of 2x? There it is. They're giving me what the derivative of g is. The only way that f and g will be parallel is if my slopes are the same. Perfect. So what we're going to do, we're going to go f prime of x, and we're going to equal it to g prime of x. Because I want to know where those slopes are the same. You have a calculator. This is a calculator question. You already know f prime is this, and then type g. We never type g prime, right? Type g prime into your calculator. So I'm going to go ahead and click on y equals. And let me see. Clear. Oh, well, yeah, I don't need them anymore. What was g prime?
1 plus
Pi cosine. Cosine of what?
cosine of
Pi x. Okay, there it is. There's g prime. And then on y2, I'm going to type in f prime. 2x minus 2. All right. Did they tell me, did they give me bounds or anything? Yeah, look, what did they give me between what? 0 and 1. Okay, you see, we all took pre-cal. You see how it says pi plus 1? That pi is in front of the cosine, so that's like my like the max this will ever be is pi plus 1. And the min for the sinusoid here is 1 minus pi. Does that make sense to you? So here's what I'm trying to say, Chavez, what are you trying to say? So here we go. I'm going to check between 0 and 1. And I know that they must intersect, right? So I'm going to put 0.5 here. So my y min, I'm going to make it 1 minus pi. And my y max, I'm going to make it 1 plus pi. Do you see what I did there? Okay. Yeah, we all took pre-cal. We all took algebra 2. And there it is. This is my sinusoid right here. Here's the linear line. One of them's f of x, one of them's g of x. Let's see, which one's g of x? I think it's the y1, right? So yeah, so now we're going to find where they what? So tell me, where do I push? Second calculate. Number 5. Thank you, miss. Boom, boom, boom. What did you get? Perfect. That's a 1. So this happens, and this happens when x equals, and then hook me up.
0.675818.
Did I write it correct? And there it is. It can be shown, find the value of x between 0 and 1 in which the line tangent to the graph of f is parallel to the line tangent of the graph of g. There it is. If you want to write a statement, you can. The f and g are parallel when x equals f and g are parallel when x equals 0.675818. We're done with that. How do you feel about those questions, those two?
I wish I had those questions.
Oh, well, yeah, because you didn't. But how'd you feel about number 1?
Good.
Okay, let's look at question 3. You had this. Do you remember this one?
I do remember.
Okay, let's look. Let's see what it says. A student starts reading a book. By the way, no more calculators, so let's put the calculators away. So I will close this guy. Bam. Right. Approximate R prime 1 using the average rate of change of R over the interval 0 to 2. Show the work that, well, I haven't even, did I read the top part? A student starts reading a book at time t equals 0 minutes and continues reading for the next 10 minutes. The rate at which the student reads is modeled by the differential function R, where RT is measured in words per minute. Select the values of RT are given in the table shown. Okay, so here's my table, minutes and words per minute, RT. Approximate R prime 1 using the average rate of change of R over the interval 0 to 2. Show the work that leads to your answer, indicate units of measure. Okay, all right. So R prime 1 is approximately, do you remember how to do this one? Yeah. Perfect. Yeah, heck yeah, you got it right, miss. You got it right. So R of 2 is 100. R of 0 is 90 divided by 2. 100 minus 90 is 10. And 10 divided by 2? And they want units of measure. So words per minute is in the top, and what's in the bottom? Minutes. So I'm going to write words per minute over minute. You could also write words per minute squared. That's also appropriate. But words per minute, pretty good. Words per minute per minute. Cool? All right, let's go to the next one. Must there be a value C between 0 and 10 such that R of C is 155? Justify your answer. Well, let's see. Let's look at that table. R of 0 is not, well, they want it to between 0 and 10. Okay, so 0 is 90, 2 is 100, 8 is 150, 10 is 162. And we know that R is differentiable. So because you're differentiable on that interval 0 to 10, then I'm also continuous on 0 to 10. So is R of C 155 somewhere? Yes, between what and what? Yes, you got it right, between 8 and 10, but you got to make sure that you state your statements. Let's see, R, I'm just going to repeat this. Function R is differentiable. R is differentiable on 0 to 10. Hence, R is continuous on bracket 0, comma 10. Since R of 8 equals 150 and R of 10 equals 162, comma, R must have, R must have a C on, and you can say between 8 to 10, but it's fine to just repeat that, on 0 to 10, where R of C equals 155 by intermediate value theorem. You got to go?
Yeah, my dad.
Okay, that's fine. Does your dad want to come in?
Can you do the last one real quick? 'Cause I just want to make sure.
Okay. And make sure that this is correct. R is differentiable on 0 to 10, hence R is continuous on 0 to 10. Since R of 8 is 150 and R of 10 is 162, R must have a C on 0 to 10, where R of C is 155. You could have also said 8 to 10, right? Since that is the numbers that we reference. You could have said 8 to 10 in there. Or C is 155 by intermediate value theorem. Or I guess I wouldn't write by. I would just say intermediate value theorem. All right. How do you feel? Okay, letter C. Use a trapezoidal sum with 3 subintervals indicated by the data in the table to approximate the value 0 to 10 of RTDT. Show the work that leads to your answer. Okay, so let's do that. So integral 0 to 10 of R of t dt equals, and so area of a trapezoid is base 1 plus base 2 times height divided by 2. So this is going to be your quote unquote height, right? So, and then the base 1 and base 2. So here we go. I'm going to zoom out so I can see. 90 plus 100, that in parentheses times 2 divided by 2 plus, help me out, what's the next one? 100 plus 150, good job, times, yes, divided by 2, good job, plus, good job. All right, be careful. You ready? Did you leave it like that or did you keep going? Okay, let's see. 2's cancel out. 100 plus 90, that's 190. Plus 2 goes into 6 3 times. 1 plus 150, I believe that's 250. So don't worry, in a little bit we'll figure this out. Plus, those 2's cancel out. 150 and 153 plus another 12, 312. And did you leave it like that or did you keep going? Okay, that's fine. That's fine. You're courageous. 190 plus 250 times 3, that's 750 plus 312. All right, let's see. 750 plus 190, 750, 850, 950, that's 940. And then 940 plus 312. 940, 1040, 1140, 1240, 1250, 1252. Unless I messed up. I mess up all the time. I make errors all the time. And if you wanted to, they're not asking. Are they asking for units? They're not asking. What is that? We're finding areas under the curve, so let's let our units help us out. RT was in words per minute. DT, the change in T, was in minutes. So words per minute times minutes is words. All right, good job. Look at you winning. And it's okay. It's okay. Look, you were under pressure. Do you think you want to do letter D here, or you got to go? Okay, if your dad wants to come in, tell him to come in. Okay. All right. I'm gonna continue because I know that you guys want to see this, so I'm gonna continue. Plus, we still got, ready? A teacher also starts reading at time t equals 0 minutes. Yeah, sorry guys. In case you're wondering, we have a student, but she's not in calculus. But she's looking. She's an algebra student, but you'll be here eventually. So, all right. T equals 0 minutes and continues reading for the next 10 minutes. The rate at which the teacher reads is modeled by the function w, defined by, and there it is, where wt is measured in words per minute. Based on the model, how many words has the teacher read by the end of the 10 minutes? Show the work that leads to your answer. All right, so here we go. So the number of words, it's kind of similar to letter C here. So the number of words, later miss, have a good one, is equal to the integral from 0 to 10 of negative 3/10 t squared plus 8t plus 100 dt. If it bothers you that I didn't put any parentheses, well then put parentheses, but it's understood the dt is the end there. So let's take the antiderivative. So the antiderivative of this, negative 3/10 t cubed divided by 3. So negative 3/10, I'm going to put a little dot there. T cubed divided by 3. In a little bit, I'll cancel the 3's out. Plus, antiderivative of this, 8t squared divided by 2. So that's 4t squared plus 100t. And I'm evaluating these three terms from 0 to 10. In this case, since you have a polynomial, you don't have to necessarily worry about the 0. You can just plug in the 10 there now. So here we go. These 3's get canceled. So now I have, let's see. I guess let me do this really, really fast. So I'm going to write t cubed over 10 plus 4t squared plus 100t. I know you don't have to do that. You can just go right into it from 0 to 10. So upper minus lower bracket. I'm just going to do the negative 10 to the third power over 10 plus 4 times 10 squared plus 100 times 10. This is my first set of parentheses minus. If you plug in a 0, you're going to get 0. And there it is. You could leave it like that, guys. But, if you're courageous, if you feel like you can go, keep going. So negative 10 to the third power is negative 1,000. So don't forget, that's going to be a negative because it's not an even power. And then divided by 10, that's going to be a negative 100. So negative 100 plus 10 squared is 100. 100 times 4 is 400. Plus, and then 100 times 10, that's 1,000. And there it is. So let's see, that is 300 there. So plus 1,000, that's going to be 1,300 words during those 10 minutes. All right, we're good. Let's keep going. Let's see what this one says. The continuous function f defined on the closed interval negative 6 to 12. The graph of f consisting of 2 semicircles and 1 like segment is shown in the figure above. Note that this one has a radius of 3. You don't have to go like that. You could have gone like that way too. And then that has a radius of 3. So it looks like those ones above the x-axis, ones below the x-axis. Let's see if that comes into play. Let g be the function defined by g of x equals, note the lower limit starts at 6 and 0 to x of f of t. All right. Find g prime of 8. Give a reason for your answer. Oh, okay. So g prime of 8. So I'm going to go g of x equals integral from 6 to x of f of t dt. And it says give a reason. So here we go. I'm going to find my g prime of x first. G prime of x, fundamental theorem of calculus. I have an x on the top. I have a constant on the bottom. This is simply f of x. I don't remember what notes I did this proof on, but you can easily find it. Just Google proof of FTC, and you'll find proofs of a whole bunch of proofs for that. So g prime equals f. So there it is. So I'm going to go g prime of 8 is nothing more than f of 8, which is, and I come here, that's it. It says graph of f right there. F of 8 is equal to 1. So there it is. What'd you think? And let's go to the next one, guys. Find all values of x on the open interval negative 6 to 12 at which the graph of g has a point of inflection. Give a reason for your answer. I love it, guys. You have a point of inflection when the second derivative of g changes signs. I don't have the second derivative of g, but I do have the derivative of g. So I'm going to write g prime equals f. And then that means I'm looking for where either g prime equals f, wherever I have a max or min, or you can say wherever you have a max or min on f, which is the same thing as max or min on g prime. Or you can say wherever g prime, which equals f, changes from decreasing to increasing or vice versa. Because, see, like I'm decreasing and then boom. And that's going to be a point of inflection for g because, why? Because g prime prime is negative, right? Because remember, the definition still holds. If g prime prime is negative, that means g prime is decreasing. If g prime prime is positive, that means g prime is increasing. Which, of course, I know it's very easy to become a robot. G prime prime being negative means that g is concave down because your rate of change is decreasing. That's what creates your concave down. G prime prime being positive means g prime is increasing, which means g is concave up because your rate of change is increasing, and that's what creates your concave up. Think about it. Like your rates of change, they keep getting steeper and steeper and steeper. That's going to create that concave up deal. All right. So here we go. Hopefully I said everything correctly and I didn't confuse anyone there. So I have a point of inflection. So I'm going to write G has points of inflection at x equals, the first one is at negative 3, comma, the next one happens at, let's see, I'm increasing, boom, at 3. Oops. And then the last one happens, look, there it is at 6. And x equals 6. Since g prime, which equals f, changes from, and I like to just state the first one, it changes from decreasing to increasing, changes from decreasing to increasing, and vice versa at those specific x values. All right, I think everything looks good. I'm happy with it. I hope you're happy with it. Here we go. Let's continue. This is still continuing. And it says find G of 12 and G of 0. Label your answers. Okay. Well, let's see. G of x was this. So let me write that. 6 to x. So G of x, 6 to x, f of t dt. So G of 12 equals integral from 6 to 12 of f of t dt. Here's my f. So this just means area under this curve, under the f curve. So I just have a triangle there. So that looks like 6. This looks like 3. 6 times 3 is 18, and half of 18 is 9. 6 times 3 divided by 2. Because it's a triangle. Base times height divided by 2. I don't see any issues. I think we're good. G of 0. Integral from 6 to 0 of f of t dt. I don't see issues. So 6 to 0. I'm going backwards. So because you're going backwards, you can put a negative there and put 0 to 6, or leave it and just put a negative in the front. See? Negative. This is a semicircle, guys. Area of a circle is pi r squared. So we're going to have to divide by 2 for this one. So that's 3 there. So negative pi 3 squared divided by 2. So negative 9 pi over 2. All right. Let's see. What do we got next? Oh, is that it, right? Yeah. Label your answers. There it is. G of 12, G of 0. Find the value of x at which g attains an absolute minimum on the closed interval negative 6 to 12. Justify your answer. Is this just like the other one? G prime equals f? I mean, I guess we could do a table, but let me see. Derivative. This is my derivative. Negative, positive, and it's always positive after that. Okay, guys, I think what I would do on this one, now, you don't have to do what I would do, but on this one, I only see one type of sign change. I only see one sign change right there. Besides that, I mean, I'm 0 at 6, but I'm always increasing after that. So I'm going to go G obtains. So I'm looking for, it says absolute minimum. So I'm going from negative to positive. Do they want the value? Find the value of x. Find the value of x. Nope, they just want the x coordinate. I'll show you both ways just in case. But I would prefer, I'm leaning on this one over the table one. I see derivative is negative, and then boom, and then positive, and then 0 for a moment, and then back to positive. So I see this. G obtains an absolute minimum at x equals 0 since I'm still thinking about the other one. Since G prime, which equals f, is negative on the interval. Let's see, it's negative on the interval negative 6 to 0. And G prime, which equals f, is positive. You know what? I should probably put a comma in there. Comma. And G prime, which equals f, is positive on the, you know what? I'm going to put equals so I don't have to write 2 intervals because it equals 0 right at 6, but it's never negative. G prime, which equals f, is greater than or equal to 0 on the interval. And I can just go bracket 0, comma, all the way to 12. Close. Semicolon. Hence, comma, absolute min on G must be at x equals 0. I like that route. But I've been preaching to my kids all year long that if you ever have a closed interval and they ask for absolute min, I've been telling them, guys, do tables. So here's the table. If you wanted to go that route, you don't have to go that route. You don't have to. I think this is good enough. And you would say you include your endpoints and you include your critical points. So I'm going to write let me go ahead. You know what? Let me color code this because it is a different route. X and G of X. I would not recommend that you do both. I guess if you do both correctly, you'll be fine. But if you make an error on one, then, guys, like, they have to deduct, right? Because if you make an error on one, you're not right. That's called parallel solutions. You guys can talk about that later on, or hit up Mark Corrali. I don't know if you're looking at this, Mark, but if you are, sorry that I'm mentioning you. To hit him up. He'll explain what this is. Or I guess I can do it too, but we're not talking about that. We're talking about this. Let's just continue. All right, here we go. Let's see. What was I saying? Oh yeah, endpoints. -6. I'm going to write G prime equals f at x equals, and I really should be writing G prime of x equals f of x when x equals Let's see, negative 6. Well, that's an endpoint 0, 0, and x equals 6. But that's neither, right? Neither max nor min. So negative 6, 0, and then I guess I'll put 6 there, and then 12. And luckily for us, look, we already have G12. G of 12 is 9. 9. And then G of 0 is negative 9 pi over 2. And then G of 6, well, let's talk about that one. G of 6 is neither, so I'm going to put NA, because it's neither max or min, right? Because it doesn't change signs. And then, Chav, what about negative 6? Well, let's see. At 0, I was negative 9 pi over 2. And then this area here cancels out with this area here. So G of negative 6 is the same as f of 6, which I never got. Wait, did I get f of 6 somewhere? No, but we don't need it. See, so I guess we should find it real quick, right? Well, G of 6 is 0. What am I talking about? Man, look, it's been a long day. We don't need it, but it's 0, by the way. And if G of 6 is 0, then G of negative 6 has to be 0 as well. So there it is. All right. Sorry, guys. Some of you probably were irritated. Like, Chav, G of 6 has to be 0 because G is this integral. 6 to 6 is 0. See? So there it is, guys. I think we're good. You don't need it. You could have done what's in red. I think both routes would have been okay. I'm thinking my kids probably did what's in blue more than likely because that's what I've been preaching all year. All right, question 5 here. Two particles H and J are moving along the x-axis between 0 and 5. The position of particles H at time t is given by, okay, so here's my position equation. And the velocity of particle J at time t is given by, so here's my velocity equation for particle J. Find the velocity of particle H at time t equals 1. Show the work that leads to your answer. Okay, so here it is. So I'm going to get the velocity of H with respect to t by taking the derivative of position. So the derivative of an exponential is itself, e to the t squared minus 4t, times chain rule. So times the derivative of t squared minus 4t, which is 2t minus 4. There it is. I'm going to plug in a 1. So VH of 1 equals, let's see, E1 squared is 1, 4 times 1 is 1, 1 minus 4 is negative 3. And let's see, 2 times 1 is 2, 2 minus 4 is negative 2. So negative 2 e to the negative 3. Yeah, I think we're good, guys. Make a note that this guy right here is never negative, e to the t squared minus 4t. That might come into play right now. Let's see. Letter B. During what open intervals in the time t between 0 and 5 are particles H and J moving in opposite directions? Okay, I already got the velocity for H. It is e to the t squared minus 4t times 2t minus 4. If you want to factor out a 2 here, that's fine. Be careful. Put the 2 in the front here and then call it t minus 2. I'm going to set this equal to 0 to see where this changes signs. That happens at t equals 2. You don't care about the e to the t squared minus 4t. E to the t squared minus 4t is always positive. So there it is. Let's find out. Let me look at the other one, the v of j. Velocity of j as respect to t equals 2t parenthesis t squared minus 1 closer to the third power. That equals 0 when t is 0. But notice that's an endpoint, and notice it's between 0 and 5, so we're not going to pay attention to that. And when t is 1, t squared minus 1, if t is 1, 1 squared is 1, and 1 minus 1 is 0. So we do have to pay attention to that. All right, I'm going to do a sign chart. Now, a sign chart's not enough. You need more than that, but I'm going to do a sign chart real quick from 1 to 5. I'm going to call this VH, and I'm going to put, here's 0 and here's 5. Those are supposed to be parentheses there. And VH, I'm just going to plug it in. I'm going to say that 2 is like right here. And I'm going to go VJ from 0 to 5. Guys, you need more than just this sign chart. Just giving you guys a warning. 1, and there it is. All right, I'm just plugging in numbers. I'm looking at my V of H, and if I plug in a 1, we don't get this right here is always positive. Always positive. But if I plug in a 1 here, 2 times 1 is 2, 2 minus 4 is negative. So I see a negative. Plus, remember at 1, I guess you didn't have to do that. You could have just looked at this one, right? And then after I plus 2, like 3, 2 times 3 is 6. 6 minus 4 is a positive number, and a positive times a positive number is a positive. So plus. And now I'm looking at the j. So if I plug it in like 0.5, the 2t is always going to be positive because we're talking about numbers that are positive for t, 0 to 5. But look at this. When you square 0.5, guys, 0.5 squared is 0.25. And 0.25 minus 1 is a negative number. And when you have a negative number and you're cubing it, so look, my algebra kid knows this. When you have a negative number and you're cubing it, is it still negative? Yeah, say it out loud. Yes. I don't know if you guys heard her, but she said yes. When you cube a negative number, it stays negative. Good job, miss. All right, so there it is. So let's see. What was I talking about? Oh, yeah. I chose 0.5, right? So negative. And then I'm going to pick a number bigger than 1, like 2. Well, 2 squared is 4. 4 minus 1 is a positive. When I cube a positive number, it stays positive. Say it aloud. Say it loud and proud. You're good. Positive. See? My algebra kid knows. So there it is, guys. So where are the signs opposite? Well, it starts negative. And then look at this. So between 1 and 2, the velocity of j is positive, but between 1 and 2, velocity of h is negative. So there it is. They said opposite directions. If velocity is positive, you're moving right. If velocity is negative, you're moving left. This is just one-dimensional motion. Chop, how do you know you're moving left and right and not up and down? Because it says x. So that's particle in the x-axis. So here we go. I'm going to go particles h and j. Particles h. Oh, you know what? Maybe I should mention where particle h, because this is not enough. Remember, it's not enough. Like Kendrick Lamar says, it's not enough. So here we go. So I'm going to say velocity h is positive on. Maybe I should have started with negative. I already started. I already wrote it. Velocity h is positive on 2 to 5. Semicolon. Velocity h is negative on 0 to 2. And then here's another line. Another blind bullet. I'm going to write velocity j is positive on 1 to 5. Semicolon. Velocity j is negative on 0 to 1. So where do I have my opposite directions? Between 1 and 2. So I'm going to write particles move in opposite direction during the time intervals, comma 0, comma 1, 2, 2. And there it is. Particles move in opposite directions during the time interval 1 and 2. Done. How do you guys feel? How do you feel, miss? Okay. It can be shown that Vj of 2 is positive. Is the speed of particle j increasing, decreasing, or neither at time t equals 2? Well, we know the velocity. Vj of 2 is, here's j, so velocity of 2 is positive. And then acceleration of j, which happens to be, let me write it like this. Acceleration of j at 2 equals v prime of j at 2 is positive. So there it is. Velocity is positive. Acceleration is positive. So particle j is speeding up, or j is increasing. The speed of particle j is increasing since Vj of 2 is positive and Aj of 2 is positive. And we made a connection between the acceleration and velocity. The derivative of velocity is acceleration, and I think we're good right there. Okay. The speed of the particle j is increasing since velocity is positive and acceleration is positive. You can also say the same signs if you want. All right, let's continue. Particle j is at position x equals 7 at time t equals 0. Find the position of the particle j at time t equals 2. Show the work that leads to your answer. Okay, so my position, let me see. I'm going to write it like this. My position for j at time 2 is equal to the initial position, which is 7, plus integral. That was the initial position at time 0. And I got to find my displacement from 0 to 2 of particle j. So I'm going to write velocity of j of t, dt. All right, so let's see what this is. 7 plus integral, 0 to 2. And velocity of j was, did they give it to me or did I have to find it? Velocity of j, right here. 2t times t squared minus 1 to the third power. 2t times t squared minus 1 to the third power of dt. All right, guys. By the way, this is just, see, so your initial position plus the displacement will tell you where you are at 2, right? So this is not a lesson. We're just going through the problem. Please look at my notes over position, velocity, acceleration, or, any Khan Academy has a good one, I'm sure. So here we go. I'm trying to integrate this. I'm looking for patterns, and I see that I have t squared minus 1, and I see that I have a 2t there. So I'm going to do something called u substitution. I'm going to say u equals t squared minus 1. So then du equals 2t dt. Once we start with u substitution, because we have limits, we're not going back to our x. This is true in calculus, and it's true in real life. You're just asking for trouble if you go back to your x. So don't go back to your x. You have limits. Now, if you didn't have limits, then it was never about you. Then I guess go back to your x. Shout out to Mark. I see him saying that often on Facebook. LOL. All right, so here we go. Let's go ahead and take care of this. I'm gonna go ahead and do that substitution. So I'm gonna go 7 plus the 2t dt. Look, there's 2 t dt there. That's gonna be my du, and then the t squared minus 1. That's gonna be my u. Integral of u third du. Now I'm gonna have new limits. So when t is 0, 0 squared minus 1, u is negative 1. When t is 2, 2 squared is 4, 4 minus 1 is 3. U is 3. Hopefully that made sense, guys. So there it is. These two expressions are equivalent. There's no reason to go back to x. Stay with this expression here. All right, here we go. So I'm going to write 7 plus, I'm going to put a bracket. Well, I guess I don't need it, but that's fine. U to the 4th over 4. Close it from negative 1 to 3. And we're brave, so we're going to go ahead and do upper minus lower. 7 plus bracket. I'm going to go 3 to the 4th power over 4 minus negative 1 to the 4th power over 4. I don't see any mistakes, but if you guys do, let me know. You can actually leave it like that if you wanted to, but we're brave. We can do this. 7 plus bracket. 3 times 3 is 9, and 9 times 9 is 81. 81 over 4 minus negative 1 to the 4th power is 1, so 1 over 4. So there it is. So I'm going to have 7 plus bracket 81 minus 1. That's 80. 80 over 4. Let's see. I think we can do that. 7 plus, let's see. 8 divided by 4 is 2. So 80 divided by 4 must be 20. And there it is. There's my position. So xj of 2 is nothing more than 27. Whew. All right. We got one more. So if you're still with me, hook me up with a thumbs up, or I guess you can give a thumbs down if you're not satisfied. All right, let's keep going. And hey, you guys should subscribe. I have some kids here, so I'm letting them know. You guys should subscribe to my channel. Okay. It says, consider the curve G defined by the equation y cubed minus y squared minus y plus 1/4 x squared equals 0. Show that dy dx equals that expression. Okay, so we're going to take the derivative of this implicitly. The derivative of y cubed is 3y squared dy dx, because it wasn't an x. We took the derivative with respect to x. I don't want it to look like a partial derivative. The derivative of y squared, so I'm going to go minus 2y dy dx. Minus the derivative of y is dy dx, so minus dy dx. Let me make sure that I got everything correct. 3y squared minus 2y minus dy dx. Plus the derivative of 1/4 x squared, 2 times 1/4, that's a half. 1/2 x dx, so there it is, equals 0. All right, I don't see any issues. I think we're good. So I'm going to go ahead and move this 1/2 x squared to the right. So I'm going to write 3y squared dy dx minus 2y dy dx minus dy dx equals a negative, and I'm going to rewrite this as negative. I'll write it like this. But this, because I want it to look eventually like that, I'm going to rewrite that. That is just negative x over 2. All right, I'm going to factor out a dy dx. So I'm going to go dy dx, factor it out. 3y squared minus 2y minus 1 equals a negative x over 2. And there it is, guys. I'm just going to divide by the 3y squared minus 2y minus 1. So when I divide, I'm going to put it right next to this, see? So there it is. So here's my next step. I'm going to go dy dx equals negative x on the top, 2, and then right next to it, I'm going to put 3y squared minus 2y minus 1. You could, I guess, if you want to go that over 3y squared minus 2y minus 1 and then keep change flip. But I think this is appropriate, and I think that's fine. And there it is. It looks the same to me. Yay. All right, let's see what the next one has. There is a point P on the curve G near 2, -1 with x-coordinate 1.6. Use the line tangent to the curve at 2, -1 to approximate the y-coordinate of P. Okay. At first glance, it looks like I'm going to need a tangent line, and I already have a point. So here we go. I'm going to go dy dx evaluated at 2, -1 equals, and I already have my expression. My expression is this. So I'm going to just plug it in, guys. So let's see, my x, -2 over 2 times 3 times -1 squared. -1 squared is 1. 1 times 3 is 3. Minus -2 times -1 is a positive, so plus 2. And then minus 1. So let's see what we get. -2 over 3 plus 2 is 5. 5 minus 1 is 4. 4 times 2 is 8. So -1/4. That's my dy dx. Let me know if I make mistakes, because I make mistakes all the time. And then here's my point. So I'm just going to use y minus y1 equals slope x minus x1 from your algebra days. So here's why we took algebra, guys. So we're going to go y minus a -1, so plus 1 equals -1/4 parenthesis x minus 2, close. And there it is. This is my tangent line. This is what I'm going to use to approximate my y value. They give you the x coordinate. It's 1.6. Plug 1.6 in there, because that's your tangent line. So I'm going to say y equals -1/4 parenthesis 1.6 minus 2, close it, minus 1, because when you move that 1 to the other side, it's minus 1. You could leave it like that, but we're brave and we're going to continue. But you could leave it like that if you want. Y equals -1/4 parenthesis 1.6 minus 2. That's a -0.4 minus 1. By the way, -0.4 is the same thing as -2/5. Remember, right? So see, 0.1, 0.2, 0.4, 0.6, 0.8. 3 over 5 would have been 0.6. 4 over 5 would have been 0.8. 5 over 5 is 1. So -1/4. So I'll write it -1/4 times -2/5 minus 1. 2, I guess you could multiply it and then reduce it, but I always have a habit of going 2 goes into 4 twice. So I always just scratch out and call that 2. Negative times a negative is a positive. So I see, let's see, 2 times 5, that's 10. So I see 1/10, negative times a negative is a positive, minus 1. Well, that 1 is like 10 over 10, right? So this is going to be a -9/10. Yay! That's your approximate y value. The approximate y coordinate of point P is -9/10. If you want to make a statement, that's fine, but I'm happy with that. College Board might be stricter, or you might be stricter in the classroom. It's up to you. For x greater than 0 and y greater than 0, there is a point S on the curve G at which line tangent to the curve at that point is vertical. Vertical, underline that. Find the y coordinate of point S. Show the work that leads to your answer. Oh, okay. Y coordinate, you want the x? You could have probably also found the x if you wanted to, but all right. Y coordinate. I have a vertical tangent. They told me there, at which a line tangent to the curve at that point is vertical. So if that curve is vertical, that means I have a vertical tangent at that point, guys. The only way you're going to get a vertical tangent is if dy dx is undefined. That denominator here is if that denominator is equals to 0. So I'm going to write vertical. And by the way, you don't always have vertical tangents when dy dx is 0. Sometimes you have a vertical asymptote. And if you have a vertical asymptote at that x coordinate, you don't have a vertical tangent. So just be aware of that, guys. I have not typed this curve into my calculator. Maybe someone out there who's a lot smarter than me can tell you how that curve looks more or less. Just looking at it, just looking at it, I can't tell you how that curve is. That's just the truth right there. Hopefully you guys like that I'm being transparent. Okay. Anyway, I have kids here, so I'm not talking to my YouTube crowd. I'm talking to my kids. Okay. Anyways, for x greater than 0, y greater than 0, there's a point S on the curve G. Oh, yeah, we were just talking about that. All right, so here we go. We just said where the denominator is 0. So I'm going to go 3y squared minus 2y minus 1. I need that to equal 0 because something times 0 is 0. Now, hopefully you remember, look, this is factorable, guys. This is factorable. At least it looks factorable. Yep. There's only one way to get 3y squared. 3y times y. Well, at the high school level, if you talk to a professor, you know what? We're not even there. We're just in Cal 1. Let's just do calculus here. There's only one way to get a 1 for the C there. 1 and 1. And then you got to add up to a -2. So let's see. It has to be, the bigger number has to be negative. So 3y times 1, that's the bigger number. It has to be a negative. And then 1 times y, that's a 1y. So that's going to have to be a positive. And there it is, guys. If you FOIL this out, you get the negative 2y, right? 3y times y, 3y squared, 3y times negative 1, negative 3y, 1 times y plus y, 1 times negative 1, negative 1. It works. Negative 3y plus y is negative 2y. All right, so I'm going to get y equal that to 0, because anything times 0 is 0. So y equals negative 1 over 3, negative 1 divided by 3. And on this one, y equals 1. 1 minus 1 is 0. 0 times anything is 0. They told me here that y is positive, so this one's out. So there it is. Is that all they wanted? There are the points S and the curve G, which line times the curve, but the point is vertical. Find the y coordinate of point S. Okay, they asked for the y coordinate. There's the y coordinate. If you wanted the x coordinate, you could have. I'm not going to put it there because then, what if I get it wrong, right? You could have plugged it in here. 1 cubed minus 1 squared minus 1 plus 1/4 x squared equals 0. You could have plugged it in here to find your x here. Those cancel out. Move that 1 to the other side. 1/4 equals 1. 1/4 x squared equals 1 times 4 times 4. X squared equals 4 square root. X equals plus minus 2. You just care about the greater than, so x equals 2. They're not asking for that, guys. That's just extra in case you want to alter this and ask this question on an exam. For you teachers out there that are looking at this, if you are looking at this, I don't know if I'm privileged enough to have teachers following my account. So there it is. Let's look at question letter D. Particle moves along the curve H defined by the equation 2xy plus ln equals 8. At that instant, when the particle is at the point 4,1, dx dt equals 3. Find dy dt at that instant. Show the work that leads to your answer. All right, guys. So what we're going to do, take the derivative with respect to t. And so here we go. We're going to do product rule here. I'm going to group the 2 with the x. If you want to group the 2 on the outside and then distribute in the end, that's fine. But I just grouped the 2 with the x. So here we go. First, times rid of the second, dy dt. Plus second, rid of the first, 2. The derivative of 2x is 2, but then remember, we took it with respect to t. So dx dt plus the derivative of ln y is 1 over y, but we took it with respect to t. Plus 1 over y dy dt equals 0. Let me make sure that I didn't make any mistake. First times rid of the second, dy dt, plus second, y times rid of the first, 2 dx dt, plus 1 over y dy dt. Yeah, everything looks good to me. They want me to find dy dt. This is my x. X is 4. Y is 1. And dx dt equals 3. You can, if you want, solve for dy dt. Our physics teacher loves doing that. I'm just going to go ahead and plug in, guys. I think it's easier for my kids. That's what I think it's easier. You know your kids the best. I think it's easier for my kids to just plug in immediately. 2 times 4, and then that says dy dt. That's what I'm looking for. dy dt. Make sure you can understand your handwriting, because then it could be easily that you don't understand your y's for your x's, right? First and rid of the second, yeah, we're good. Plus y, my y value is 1. I know some of you at irks you want to see 2y dx dt. That's fine if you want to 2y. See, I said to x and 2y dx dt. But it doesn't bother me, so I'm just going to go y times 2 times what was my dx dt times 3 plus 1 over 1 times dy dt equals 0. All right, so I think we're good. Let's see, 2 times 4 is 8, so 8 dy dt plus 1 times 2 times 3, that's 6, plus dy dt equals 0. So I see an 8 dy dt and a dy dt, so that's going to be 9 dy dt. And I'm going to move that 6 to the other side, negative 6. And there, we pretty much got it. Just divide by 9. dy dt equals negative 6 over 9, which is the same as negative 2/3. And we got it, guys. All right. Well, that's the last one. Hopefully, time went by pretty quick, and I hope you enjoyed this. If you did enjoy it, if you want to give it a thumbs up, if you want to give it some love, that's fine. If you see some mistakes, let me know. And yeah, we'll call it a day, guys. All right, later. Bye.